Welcome to the Stinson Visiting Professorship. We've had a visiting professorship that generally focused on translational surgeon scientists. And last year, Mike Fishbein and I thought about this, and we really wanted to honor Ed Stinson. And we thought, well before the term translation was popular, Ed Stinson was doing this. Now, Ed Stinson was a chief resident during Dr. Shumway's very first heart transplant here at Stanford. That was 1968. And, Dr. Shumway's credited with inventing the operation and moving it forward. Ed Stinson did a lot of the work in the lab, before and afterwards. And not only in the lab, but in the clinical environment, and served as the principal investigator for a PO1, that's a giant R01, for many, many years, decades afterwards, to really move the science of heart transplantation forward. Until almost 15 years later, did heart transplantation become really like a gold standard, widely adopted therapy. And that's really a lot of the stuff that's not very well known, and Dr. Stinson really deserves a lot of credit for pushing heart transplantation forward. There's one fun fact, and that is he's also a co-author on the other topic that Stanford's really well known for. So Stanford's really well known for heart transplantation, but then of course all the innovative work in aortic surgery, and particularly the 1970 publication that determined the classification system for aortic dissection, type A and type B. So if you're anywhere in the world other than Houston, Texas, you use the Stanford classification system, and Dr. Stinson is a co-author on that paper, and he's the last living co-author on that paper. And not only is he living, but he's alive and well. And Dr. Miller and I just saw him 2 months ago here on the campus as he was receiving an award from the School of Medicine as one of the most distinguished alumni. And Dr. Stinson is quite engaging and very fun to speak with. And he was very, very honored to have this professorship named after him. And so when we were thinking about, well, who would be the perfect person to bring as the first Stinson lecturer? And it didn't take us long. And we said, well, obviously, it's Pedro del Nido. There's really no one in our entire larger specialty that embodies clinical skill, scholarship, mentorship, and leadership. All the things that Stinson represented are packaged in Dr. del Nido. And in our modern era, there really is no one quite like Dr. del Nido. Now, he is the chair of cardiac surgery at Boston Children's, arguably one of the greatest congenital heart surgery programs in the world. And he's a very talented surgeon. Many, many different techniques and skill sets across the entire spectrum of congenital heart surgery, a real innovator in valvular surgery in children, particularly complex valve repair. He is a scholar. He has over 600 publications to his name. 600. Think about that. Some of us are working on 6. He's got 600. He's also served in multiple capacities at the NIH. And as a scientist, he is very well known for something. So imagine having your name spoken in just about every single operating room every single day. When Dr. Chitwood was here as a visiting professorship, I told everyone that, we use the word Chitwood quite often, right? We always say Chitwood, and then they hand you a clamp, right? But that, occurs in a small subset of the ORs. Well, think about del Nido cardioplegia. Not only do we utter that word, his name, every day in the OR, but we utter it multiple times. We say, antegrade del Nido. And someone else says, antegrade del Nido. And then when that's done, you say, retrograde del Nido. And then, you get retrograde del Nido. And then later on during the case, you might say, give some more del Nido. And so the term, your name, is uttered so many times And the best thing I like about this is about 10 years ago, I was using Del Nido, and Dr. Del Nido came up to me in Japan. We were at a meeting, and he said, you're using it incorrectly. It's meant for children. It was never meant for adults. And I said, well, it's too late. There's probably, millions of cases going on in the United States and, elsewhere in the world every day where they're using Del Nido in adults. It's sort of gotten out there. And then when he heard about retro Del Nido, he's like, oh, this is totally, it's been totally, there's been a bit of indication creep. So, that's Pedro as a scientist. As an engineer, he's developed multiple innovative devices. You're going to hear a little bit about something that I've been keeping track of for quite some time, and that is an expandable heart valve. It makes total sense for children. But if you think about it, not only would it work well in children, there would be multiple applications in adults. Right now we're doing TAVR valve and valve. Well, imagine if the valve that you're TAVRing into started as an expandable heart valve. Then you could get multiple TAVRs in there. He might put all of us out of business because everything's going to be TAVR valve and valve, and TAVR valve and valve. As an inventor, he's created multiple startups, spun these out to be full-fledged companies. He's a mentor. He was a mentor specifically to our Christina Green and our Peter Chu, who I think many of us remember quite well. And as I hear, Dr. Peter Chu is doing quite well under Dr. Del Nido's leadership. As a leader, national leader, Dr. Del Nido was very instrumental in major advances at the American Heart Association, and then of course at the AATS, where he rose to presidency. And he has been an advocate for many of us in this audience and throughout the nation through the AHA and the AATS, and we're all very grateful. And then lastly, I think most importantly, Pedro, you are a friend, a very close friend to me, to many of us here, and I think that's the thing we value the most. And thank you so much for joining us.
The topic that I was asked to talk about is something that I sort of dedicated my last, I would say, decade and a half to working on. And I'll talk a little bit about why it's become an important topic for me, and I think an important topic for our entire field. And that is heart valve disease. It impacts, I'm going to talk primarily about the young, and as I get a little bit older, the young begins to creep. So I'll say a little bit about adults as well and how this technology will impact adult. But there's a lot going on. There's a lot going on here. There's a lot going on all over the world. And I think in 5 or 10 years, we're going to have a very different technology available. So let me walk you a little bit through it. These are my disclosures. These are all startup companies. Most of them are pediatric. And the main reason for that is that nobody else does anything for pediatrics. And so you have to do it. You have to create the technology. You have to create the company and then convince the rest of the world that, yeah, it's a good thing to do. So this is the outline. I think it's important to just give a background of what are we talking about here? What do we mean by valvular heart disease? Because I think it's important to think about it in that context. We do have to talk about reconstructive. It's not just about replacement therapy, but there's been ongoing controversy as to what is the best way to treat rheumatic valve disease, and this is probably the best study that I can, and most recent study, where it really, if you think about it, it explains the whole problem. This is from Malaysia, huge experience, and this is the survival curves for 3 different types of treatments. In green is bioprosthetic valve, in red is mechanical, in blue is reconstructive surgery.
I wanted to ask, my colleagues that work in Rwanda, Kenya, and some of these lower middle income settings say that, rheumatic valve disease is very different there compared to here, for example. A lot of the patients there have end-stage disease, and the average age is about 25 years old.
Oh, yeah. Norwood, I mean, the first time I saw Norwood operate, I couldn't tell.
Welcome to the Stinson Visiting Professorship honoring Dr. Pedro dinner. We had a wonderful day with Dr. Nido today. He treated us to a highly innovative lecture, then very insightful professor rounds, and then met with several of our residents. I hear that most of our residents were well behaved. I hear that the residents from Harvard were bad-mouthing the Stanford faculty. We'll deal with that later, Perry. And then Mike Ma took Dr. Nido over to the Children's Hospital. And it sounded like there were rose petals on the floor because everyone over there has heard of Pedro Nido, head of Boston Children's, and they were all clamoring to get a chance to meet with him and actually get to, just like touch his arm. So I hear that there was a fireside chat, and it was actually a fake fire there. Is that true?
Yeah.
Yeah, that's pretty good. So fireside chat with environmentally friendly fire. So Pedro, we wanted to again just welcome you to Stanford. Thank you for sharing your time and your wisdom. We want to congratulate you for all of your vast successes. And most importantly, we want to thank you for your friendship, your mentorship, your advocacy for so many of us here tonight and others at Stanford over the years. We owe you a lot.